Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. So, as you know, a couple of weeks ago, I announced the first anniversary of the podcast, and to celebrate it, our first anniversary listener appreciation contest. I want to start this show by thanking everyone who participated in the contest. You all have come out in droves over the past couple of weeks to shower the podcast with love, and for that, we are humbled and forever grateful. Overall, we received nearly 100 entries via our website and iTunes from listeners from 16 countries. Your stories have been awesome, and we're most proud that we can help light that AI fire for you every week. Of course, everyone who entered will receive a couple of TWiML and AI stickers, one for you and one for a friend. Those will be on their way soon. But now, the moment you've all been waiting for. We have our winners for the first anniversary Listener Appreciation Contest. Just a reminder, our grand prize winner receives a bronze pass for the O'Reilly AI conference at the end of this month. And our runner-up winner gets, well, hey Google, what's the second prize?
The second prize in TWiML's first anniversary Listener Appreciation Contest is a brand spanking new Google Home. Like me.
All right. Without further ado, our second prize winner is Anchor Patel. Anchor wrote in on the show notes page with this. TWiML, congratulations on your first anniversary. I have loved listening to the show. I remember the news and machine learning from the first few months. What a sheer amount of information. But the more recent interviews format is excellent. I particularly love the ones where you interview folks at AI and ML conferences. Very insightful indeed. Thanks for contributing to the broader ML community. Well, thank you, Anchor, for being a loyal listener, and we'll be in touch with you about that Google Home. And now, our grand prize winner is Mason Grimshaw. Mason also wrote in via the show notes page. Here's what he said. The show is fantastic. I started listening right when you switched to the interview format, and I've definitely noticed your improvement as a journalist and the improvement of the show. Great job. I go to school in Boston, so the show keeps me company on my 20-minute walk to school every morning, and I couldn't ask for a more interesting companion. I'm studying analytics, and while I may not directly use AI in my profession, I certainly use it as a hobby. I really enjoyed Carlos Gestrin when he came on to talk about the Lime paper and the Danny Lang discussion about video games. Well, Mason, we hope to see you in New York in a few weeks. Congratulations, and thank you for being a loyal listener. Although there can only be one first prize winner, we'd like to give everyone the opportunity to attend the O'Reilly AI conference with us. With the code PCTWiML, that's PCTWiML, all of our listeners will get 20% off of registration fees when purchasing passes for the conference. Please let us know if you're planning to attend the event. We're looking forward to meeting up with TWiML listeners there. Okay, to continue with the O'Reilly AI theme, this week I've got a very special guest. I've invited my friend Ben Lorica onto the show. Ben is Chief Data Scientist for O'Reilly Media and Program Director for Strata Data and the O'Reilly AI Conference. Ben has worked on analytics and machine learning in the finance and retail industries and serves as an advisor for nearly a dozen startups. In his role at O'Reilly, he's responsible for the content for 7 major conferences around the world this year. In the show, we discuss all of that, touching on how publishers can take advantage of machine learning and data mining, how the role of data scientist is evolving, and the emergence of the machine learning engineer. Hey everyone, I am on the line with Ben Lorica. Ben is the chief data scientist at O'Reilly Media, and he's also responsible for content for both the Strata Data Conference as well as the O'Reilly AI Conference. Hey Ben, how are you doing?
Great to be here, Sam.
Awesome. So every time I talk to you, you are just getting off of a plane, and it sounds like that is the case this time as well.
Yeah, so we had an outstanding Strata data conference in London. Yeah, basically many people from many different parts of Europe came and spoke and attended. And this year in particular, we had concerted effort to focus on deep learning on the machine learning side. But the staple topics of Strata were still remain popular, particularly on architecting big data applications.
Okay. Awesome. Well, I thought we'd start this conversation by having you spend a little bit of time talking about your background and how you got started with data and, how you kind of your path leading up to O'Reilly.
Sure. So I have a PhD in math and focused on nonlinear partial differential equations. And towards the end of graduate school, I became interested in a specific set of differential equations called stochastic differential equations, which turn out to be at least theoretically important for quantitative finance. So I had some interest already in kind of the industrial applications of what I was doing, but I definitely was on the academic track. So after grad school, I was an academic for 5 years. Okay. But then at some point, I decided I was actually much more interested in industry. And at the risk of dating myself, at least at the time when I was contemplating moving to industry, there was no data science track. So the exit strategy was becoming a quant, and so that's what I did. Okay. I did that for about 2.5 years in a small hedge fund, designing trading models, risk management, portfolio management, and things like that. And one of the first things I learned, of course, is the stuff I thought was going to be super important, the stochastic PDEs. While good to know, not exactly what I needed to do for my job. So at that time, actually, the term machine learning, I would say, was kind of nascent. The people were still using the term data mining, and so that's what I did at this. Okay. I applied basically statistical techniques in machine learning to financial time series. But then at some point, I realized my interests actually were much more on the tech side, the programming and building software applications for analyzing these time series. And so then I ended up moving to Silicon Valley around, actually, believe it or not, at the peak of the NASDAQ at the time, which was around March 2000. and so then I was here just in time for that first bust. And then
that first bust, yep. I was there around the same time.
Yeah. And so
do you keep track of what's going on on the quantitative side of the financial markets and how the technology has evolved since you worked in that space?
I not that closely. I still have friends, and obviously, my work leading these two big conferences that you described, Strata Data and the O'Reilly Artificial Intelligence Conference, brings me in contact with people working in finance. So I keep track of it that way. So to some extent I do, but I'm not immersed in the latest techniques that they're using. Although I would say that they are actually moving more towards our world, of using machine learning, alternative data sources, big data, and some of these more bleeding edge machine learning techniques, including deep learning. So to the extent that they're actually showing up at the events I organize, that's how I keep track.
Mm-hmm. Okay. So I interrupted you. You.
Oh yeah. So then at some
got
point
into the technical side of things.
I got into the technical side of things, and when I first moved to tech, I think this won't surprise a lot of your listeners, but one of the big users of data in tech are the marketing and sales people. So that's how I kind of moved into tech. Was basically took what I learned in finance and started applying it in marketing and sales applications. So did a couple of startups, joined a couple of startups that didn't really take off, and then eventually at some point ended up at O'Reilly as a data scientist working on the types of data that we have, which is a lot of it is sales data, but a lot of unstructured and semi-structured text. So I was definitely one of the first people doing a lot of this text mining and machine learning for text from the early days. I mean, I may have been one of the first people to actually use this topic models LDA that David Bly, Andrew Ng, and Mike Jordan wrote about for an industrial consulting project. So.
Oh wow! Can you tell us a little bit more about that?
I mean, so it's with a well-known tech company, right? So hired us at O'Reilly to analyze our text sources, unstructured text sources, which include all the job postings in the U.S.
Okay,
and things like that, and to just give them strategic advice. So I thought using LDA and topic models would provide some quantitative basis for the advice we were giving. And from what I understand, it did change the direction of this major tech company that everyone knows about.
So I guess one thing that I've been meaning to ask you for a while now, actually, is, you've now got 5 Strata conferences, right? And the 2 AI conferences. And I think you're involved in all of those. Is that right?
Yeah. So I'm responsible for the program for all of those. So basically everything we have at these conferences, we have 2-day trainings, we have tutorials, and we have sessions, and then we have keynotes. So basically, I'm ultimately the person responsible for the lineup for all these conferences.
Okay. And so my question then is, do you actually have any time for doing data science at O'Reilly nowadays? Or are you, how could you possibly with all of these conferences?
I would say that it's become less and less, right? So I think, I think as we kept adding more conferences, and as you know, many of these conferences are spread out across geographic regions, right? So, so we have conferences in the U.S., but we have conferences in Europe and Asia, and so I've found myself with less and less time. So to be honest, so now I'm much more less of a practitioner, more of basically watcher from afar. But I think that my background and my ability to read the original papers and talk to the researchers, many of whom I've known for many years, I think I still have kind of some feel, but maybe not as much of the hands-on feel that I would like. But I would say that the trade-off for that, though, is I've gained a much more global perspective, right? So I don't know to what extent you've organized events, but for us, particularly since we organize events across the world, you can't really just take your set of speakers from California and take them to somewhere else, right? So you really have to know the local scene, the local companies, the local communities. And so, to me, I kind of I found that very kind of rewarding, right? So that I know the data scene in Southeast Asia, in China, in Europe, and things like that. So,
Well, one thing that if we could maybe spend some time talking through a little bit of the kinds of problems that you tend to see at O'Reilly with regard to, data science and machine learning and AI and the types of approaches and techniques that you are using to solve them. I think listeners would enjoy hearing a little bit of that detail.
I think at this, like many companies, this is not going to be a surprise. O'Reilly is an older company. It's not a startup. So we do have many different systems. Some are kind of the new bleeding edge open source systems. Some are older proprietary systems, right? And so to believe it or not, one of our main problems is still to this day data integration. I mean, just because we do have many systems, just getting the data all together in one place it remains a challenge.
Yeah.
And then beyond that, I think luckily we do have a team dedicated to the data engineering part. Okay. But it remains for us. It remains a work in progress because we also keep adding systems that we're using. Because there's many software as a service these days, right? So different parts of the company start using different things. So that's one problem. The other problem is still, I think a lot of our data is still unstructured, right? So I mean, I guess there's some structure. I mean, so if you think about books, there's some structure there, right? So, but we also now, I don't know to what extent you're following our Safari platform, which is increasingly relying on, for example, video, right? So,
okay.
So there's a lot of data that we rely on that remains unstructured, and one of the challenges for us too, as a kind of a media company that is building a learning platform for training, is to take all of these many data sources, both structured and unstructured, and organize. So it turns out actually that search and a nice human curated taxonomy is still kind of remain the basic problems for companies like us, right? So let's say, for example, you wanted to learn something in a new field of machine learning, right? So we may have thousands and thousands of sources because our Safari platform doesn't just rely on our content; it relies on our content partners as well. So we will have to organize. You can do a search, so that's one way for you to probably navigate our Safari platform. But increasingly, we're finding that people want kind of curated content, right? So how do I learn about this new topic? Well, we'll use kind of the combination of humans and machines to organize a learning path for you, or a resource center inside Safari. So I think that whole taxonomy creation and grappling with data integration and unstructured data, those are our main challenges. Yeah.
And have you invested much in personalization using some of the machine learning and AI techniques that folks are using for that kind of stuff?
I think I would say we're still in the early phases, work in progress. Yeah, that's a good point, to be honest, because people learn differently, right? So each individual will learn differently from another. And so to the extent that we are, at least on our online division, we are trying to build the best learning platform. So a lot of that will increasingly have to rely on personalization. But I would say we're still in the early stages.
And do you have a particular, vision in mind for how, how the technology is put to use to enable, a certain kind of experience? Like, do you have a sense for what that experience, looks and feels like, and how it's different from, what someone might experience today, and then what the supporting pieces might need to be?
Yeah, in our case, because, for example, many Safari users use them through their companies. Let's say you work for a large company that has a subscription to Safari.
Right.
So it will be kind of a combination of us serving you content personalized to you, but us also serving you content that kind of reflects what your particular organization is emphasizing, or the rest of your team members are learning about. So
okay.
Yeah, and then the other thing, Sam, actually I should mention, is that inside Safari we now have live online training on many of the topics that your listeners might be interested in, including big data, infrastructure and architecture, machine learning, data science, and increasingly we're finding actually there's a lot of demand for content that I would describe as much more non-technical. So a lot of people are grappling with, they read about a specific topic, they may not need to implement it right away, but they need to know at a high level what it is about, and should they be bringing that into their company, and if so, what are some of the steps they should do to integrate the such and such technology or technique into their existing products.
Well, so you talked a little bit about the kind of exposure you get, in terms of in your roles with the different conferences. I'm interested in kind of taking your temperature on, the various trends you're seeing out there and what you're finding most interesting.
So good. So I just gave a keynote about this in Israel yesterday.
Oh, really? Oh, awesome.
Yeah. So I would say on the machine learning side, last year I kind of told people that this year I think deep learning will become a machine learning technique that people in the data science community will start using. So as you know, deep learning is a lot more associated with the other conference that I run, which is the AI conference,
right?
Where they're grappling with data from images and video and audio, so computer vision and speech technologies and things like that. So what we're seeing is there's a lot of hunger in the data science community to see if they can take deep learning and use it to replace some other existing machine learning technique that they're using. So, for example, some people are looking at it in terms of recommender systems. Some people are looking at it to replace how they do search rankings and things like that. So that's one trend. And so on the data science side, the other thing we're kind of seeing, and this might at this point be much more of a Bay Area thing, is that people are starting to talk about a role that kind of is a hybrid between the classic data scientist and the data engineer. So a lot of people use the term machine learning engineer.
Right.
So what it is basically someone who is maybe a little stronger on the software engineering side.
Okay.
Right. So they write code with the express intention that this will be deployed into production. So it's not one-off, sloppy. And then they also tend to think much more holistically. So if we're going to deploy this into production, what is our logging infrastructure? What is our A/B testing infrastructure, and so on? And then so then the emphasis is on production and less on prototypes.
Okay. It's interesting how the role, these roles just keep being redefined, right? I think a few years ago, the big conversation was that we actually thought of the data scientist as this monolithic person, right? That needed to know how to do everything, right? They needed to be, statistically savvy, know the math behind, the analytics and the machine learning stuff. They needed to, understand how to get data from all these systems because, their reality was that they spent, 80% of their time or more just kind of shuffling data around. And then we started to get the roles started to split off a little bit. And you started to see, data engineers, being thought of as separate from, machine learning people. And in some places you'd pair those, those two with, data engineers being, separate from your data scientists. And in some places you'd pair those two with, your real professional programmers / software engineers. Now it sounds like you're saying, we kind of came up with a new name and it's, again, it's this kind of unicorn that's supposed to know how to do everything. Am I reading it? Am I reading that right?
I would say no. I mean, I slightly, yeah, but I think the original term of data scientist was exactly what you described, which was the unicorn. This is not someone has a PhD in machine learning necessarily, right? So maybe the background here is much more of this on the engineering side, and then they learn it enough machine learning to know how to basically build machine learning enabled products.
Got it.
And part of that is that the emphasis on production means also knowing what to do with these models once they hit production, right? How to tell when a model gets stale, and things like that, and when do we need to retrain it. So, but I would say the background might be much more on the engineering side, and then learn enough machine learning to start being able to move much more fast, right? So, and there might still be data scientists in the organization to kind of build the prototypes, but increasingly, I think at least the simpler machine learning things, maybe this machine learning engineer can take on. And in fact, actually, if you talk to companies that use a lot of deep learning, they even have a much more specific role, which they call the deep learning engineer, right? So, okay, so then other trends. So on the data side, so the other thing that I've been pointing out to people is this notion that we've had a lot of progress in machine learning, right? So you can just read online publications, and there's all sorts of papers being released, lots of interesting developments, right? So, and that's great, right? So, but then what I've been telling people is, imagine a scenario where nothing happens on the research front for the next 5 to 10 years, or next 5 years, right? So, I mean, so my position is that there's still so much low-hanging fruit in many companies, including us, O'Reilly. That you can just take what we know now. You can take what we know now and implement it, and we're going to be fine. We're still going to be fine, right? So, like I said earlier, Sam, we're still grappling with data integration, right? So.
Right. Yeah, and I don't think that you guys are necessarily unique among enterprises. I think there are some large, sophisticated enterprises that are kind of at the front edge of this thing, but a lot of folks are really just in the stage of trying to figure out where it fits and how to best apply it and where they can extract the most value, and how to put together the teams to be able to do it because of the talent shortage, as you're well aware.
Yeah, and then to be honest, there's been a lot of progress. So now we have to take a lot of those ideas and use them. And to a large extent, actually, I think that while we have been fascinated with kind of horizontal platforms, I think a lot of the interesting applications of these machine learning models will be in kind of verticalized applications, right? So, and I think we'll increasingly see companies uh, specialize in serving these industries.
Mm-hmm.
And interestingly, actually, there's a intersection with the AI community in the sense that while we read a lot about the general AI, actually the way the VC community and the investors, at least when you talk to them, have been investing is they're investing in focused applications, right?
Sure.
So
Sure.
whatever that might be, security, drug discovery,
Mm-hmm.
and things like that. So the other thing that I've been talking to people about is training data, right? So we sometimes forget that a lot of the developments in deep learning really relied on the existence of large labeled training data sets.
Right.
And to the extent that if you survey companies, I think that still remains the bottleneck, right? So it's not the models,
Mm-hmm.
it's not delivering great models. It's just coming up with training data.
Right.
And there's a lot of interesting things happening, right? So in the deep learning community, you have these generative models, mostly around generative adversarial networks, right? But then also in the data science community, there's interesting work, for example, by my friend Chris Ray at Stanford, who had a system called Deep Dive, and now the next generation is Snorkel, where they basically are able to take noisier data sources. So they start with less labeled data, supplement it with noisier data sources, and then they're able to build much more accurate models. So I think there's a lot of we sometimes forget the importance of data. And so I think there will be still a lot of interesting research in how we get to training data sets much more efficiently. And then on the machine learning side, the other thing that I've been talking a lot about recently is real time or live data. So here I owe my inspiration to the Rice Lab, the successor to the AMP Lab. So the AMP Lab, as people know, is the lab that originated Apache Mesos, Apache Spark, and Alexia. So the new lab, RICE, stands for Real-Time Intelligent Secure Execution. So live data is basically think about an agent interacting with an environment, right? So a user interacting with a website, a robot navigating its environment, self-driving car, a player playing a computer system playing a game like an Atari game or Go. So there you have an environment, you have an agent interacting with an environment. So in the classic reinforcement learning sense, you're trying to learn a policy, right? So given a state of the environment, what action should I take? But if you actually take a step back and kind of look at the flow of data in these types of applications, the first part looks a little bit like what we've been dealing with in recent years. So it might look like a streaming application. So you have data ingestion and things like that, stream processing and things like that. But the machine learning part is slightly different, right? So in the reinforcement learning sense, you're trying to learn this policy. You have to run a lot of simulations. You have heterogeneous computer graphs. And if it's truly a live application, you need to have millisecond latency, right? So then it turns out the existing frameworks we have are not able to do machine learning in these really live dynamic environments. Yeah. So the classic tools that we've been using aren't able to do the machine learning you need in these environments, which I think increasingly will be much more common, right? So as as the tools get better, the use cases will become much more clear. So the people at Rice Lab took a look and kind of surveyed what's out there, and then they realized that computational framework for these types of applications don't exist, right? So then they ended up building one called Ray, which is out in alpha, and actually we're going to do a tutorial on reinforcement learning using Ray at our AI conference in San Francisco. But the other thing I wanted to emphasize here is that the interesting thing to me is kind of machine learning in this live environment, right? So
right.
It turns out right now that people are using reinforcement learning, but there's other techniques that might emerge.
Mm-hmm.
And the interesting thing about Ray is that you can use it for reinforcement learning or other approaches. So, for example, the OpenAI folks recently published a paper where they use evolutionary algorithms, right? So
Okay.
to solve some of the things that you would do with reinforcement learning. But the interesting thing is that the Rice Lab people took that paper and then basically they just implemented this evolutionary algorithm in Ray, no problem. So, like I said, I think the tools are kind of a work in progress, and that includes Ray. And as the tools get better, then people will start using these tools, and then the use cases will be much more clear. But
Right.
basically, think about any kind of dynamic setting where you want to be able to take advantage of machine learning.
Mm-hmm.
And right now, I would say, Sam, that my other conference, the AI conference, is definitely much more aware and interested and focused on these types of applications. So, for example, we're already seeing that reinforcement learning content and tutorials are very popular at that conference. But I think as the tools get better, maybe we'll start seeing the data science community start using them too, right? So, for example, look back 3 years ago, deep learning would have been inaccessible to the data science community, right? So we didn't have the tools like TensorFlow, MXNet, BigDL, and PyTorch, and all these things. But as the tools got better, people start kicking the tires, right? So, go ahead, Sam.
I was just going to drill into your comment about reinforcement learning. Typically the literature in talking about reinforcement learning is looking at kind of an agent exploring an environment and trying to maximize some policy. So the off-cited example is like an agent being trained to play Atari video games like Breakout and maximize their score. Do you have a sense for how this translates into the real-time, streaming machine learning example that, or even industrial, enterprise type scenarios?
I think that the use cases still need to be worked out, but you can imagine personalization on a website, maybe, right? Mm-hmm. So where you're interacting with a website, much like you're interacting with a game,
right?
It's on the AI side, you can see applications in autonomous vehicles and drones.
Sure.
Maybe in inventory management, if you really need real-time inventory management. Definitely the finance people might be interested in this from trading strategies or portfolio design. And then resource allocation, if you imagine a scenario where resource allocation with live data becomes prevalent. But definitely robots are in any kind of robotic environment, right? So robotic application is already using it. But I think I imagine a scenario where if the tools get better, the people will probably find the right use cases.
Sure. Yeah, one of the other things that I find interesting about the whole real-time machine learning scenario, and let me know if you have come across this or have any thoughts on this, but there seems to be in those kinds of environments a merging of, traditionally your training and inference are two totally different things. And when we're talking about kind of real-time streaming data, more and more, I see people wanting to do things like active learning where the learning is real time in addition to the inference, which, folks more easily do real time now. Is that what you're seeing as well?
Yes, to some extent. I mean, I think that the use cases that I'm interested in tend to still separate the training and inference. I mean, the use cases that I'm much more familiar with tend to still separate the training and inference. I think there are people who are kind of pushing the envelope towards much more of this online learning scenario. But then now we start getting into the scenario I just described, right? So we're just kind of learning really with live data and interacting with an environment, right? So where simulations and explorations, the ability to do those at large scale at very low latency come into play, and those scenarios are really quite different.
Yeah.
And actually, this is a good segue to the last thing I wanted to emphasize, which is compute, right? So we're in the age of big models, which is deep learning, big data, which is training data, and live data, and big compute, right? So as you mentioned, in this scenario, we need everything, right? So we need scale, throughput, latency, all of that with low power consumption. So I think there's a lot of interesting things happening there, like what is the future infrastructure for machine learning, right? So I think those are still very active areas, a lot of things happening at a rapid clip, right? So both from the GPU side, the CPU side, FPGAs and ASICs and all of that, right? So, so I think sometimes people forget that to make all of this work, you still need hardware,
right? Right.
And hardware, there's a lot of trade-offs when you get to hardware.
Yeah. Yeah. Unfortunately, I think for a lot of people working in the space, you can't forget it enough, right? I think over time, the level of abstraction is going to have to raise where people, can just, have the full flexibility to do the things that they want to do without having to think about, how they configure their, jobs to run on GPUs or distributed or what have you. But still, I think a lot of thought still has to happen. More thought than it should be, right?
Yeah, but I think I think we're getting to the point where you've got these tools for hardware and software acceleration, and then the software libraries. So I think that for most practitioners, the only time they'll think about it is when they look at their bill, right? So,
nice.
At least for most practitioners, right? So, but then for the bleeding edge researchers who have to worry really at the low level, like at the level of interconnects, and things like that, because they're trying to break or set the record for speech recognition. A lot of that still matters, but for regular people, it's just the cost, I think, is what they're going to end up. That's how they're going to know what they're using. Right? So.
So the other thing that, or another thing that I often enjoy chatting with you about is the, interesting startups that are, doing interesting things, both in Silicon Valley and around the world. What, anything come to mind there? Or, I'm particularly interested in, ones that we don't hear about all the time that, maybe in, other parts of the world.
There's a bunch of startups in China that I'm not sure people here have heard of, but just generally around applying deep learning to whatever vertical, right? So manufacturing, drones, and to some extent similar applications that we would see here, but for that market, right? So for speech recognition and intelligent chatbots and things like that. But I would say actually, so if you look at the AI, so the one country that I think is really interesting in terms of its excitement and fascination for AI is China, right? So because just organizing a conference there, and people just are dying for content in this area. So in terms of startups, I would say, I don't know how you feel about it, but I'm really interested in the startups that are much more focused.
Yeah.
Because, I think the whole, if you're going to do a platform, it's going to be tough to compete with these cloud providers, right? So unless you have a platform that's focused on a vertical, maybe, right? So, but, Amazon, Google, Microsoft, they have pretty impressive tools for doing almost the end-to-end, right? So for building these applications. But if you are very, very focused, I think that's where you can excel. So you might be a focused startup on drug discovery, or even actually you can take an area like computer vision, right? So I happen to advise a startup called Matroid that's trying to be kind of a computer vision enabler for many companies. So then they can take kind of much more of the product approach in terms of how do companies use this easily to solve problems, right? So whatever it might be, summarizing surveillance cameras and things like that. I guess you can build all of these things yourself using existing tools or the cloud, but they already have a product that your analysts can use, non-programmers, right? So I'm quite interested in companies like that. I've been trying to kind of get as you mentioned earlier, as to whether I pay attention to finance. I've been recently trying to figure out what's happening in finance on some of these technologies, and I haven't. I don't have a quick answer, right? So it seems like there's a mix of hype and reality, but finance is kind of also a peculiar industry in the sense that maybe the most interesting things are happening in companies who don't want to talk to you.
Yeah. Finance can be like that, what I mean? Right?
So recently, for example, I had one of my editors. I introduced him to a bunch of companies, right? So in finance, and to try to get a handle on what's happening, and it's just hard. The people that we think are doing interesting things don't want to talk. So
yeah.
What else? So I think like I said, data is still going to be an important thing. So I think people who have interesting data, who are able to take public data and make it usable, right? So I guess Chris Ray and Mike Caffarella have this notion of dark data, right? So taking data that's very unstructured, and making and infusing it with structure so that you can use it for applications. Because I think there's still a lot of competitive advantage to people who have good data.
So what's next? Well, the AI conference is next. Literally, it's coming up at the end of June, and I mentioned to you that this podcast is going to be published at the same time we're announcing a winner of a ticket giveaway for the AI conference. And one question that I had for you was, I attended the first one. It was a great event. Had lots of great conversations there, heard great talks. What's going to be different about the second event?
So a few things. One, the first event was a 2-day event. We did not have training or tutorials. So at this event, we will have both. So for example, we have a 2-day training on deep learning with TensorFlow. And then a bunch of other trainings, and one that stands out is a 2-day training on NLP with deep learning with my friend Dilip Rao.
Oh wow!
And Dilip is also the organizer of a fake news challenge, and so the winners of which will present at the conference.
Is this generating
and
or
on the
detecting?
tutorial side? Detecting. Yeah. And on the tutorial side, we have a bunch of interesting tutorials from reinforcement learning. In this particular edition of the conference, we're actually going to offer tutorials on a variety of deep learning frameworks, right? So not just TensorFlow. We have Big DL and MXNet.
Okay.
We're also trying not to be we're trying to be the industry gathering place for AI, where you can learn about many different techniques in AI and how to use it in your organization or your company.
Okay.
So to that end, we're also going to offer trainings in non-deep learning techniques like probabilistic programming. And what else? So the other so reinforcement learning is a popular tutorial. It's emerging, as I mentioned earlier. The other popular tutorials are ones aimed at the non-technical audience, right? So how do I manage an AI project? How do I bring AI back into my company?
Right.
And then on the keynotes are going to be great, right? So we have Dave Ferrucci, who led the IBM team that won Jeopardy, the quiz show.
Okay.
So he hasn't spoken in many years, but he has a new research outfit called Elemental Cognition.
Mm-hmm.
So he's going to give a keynote about what they're up to, which is basically they're taking one of the grand challenges of AI, natural language understanding, and basically trying to come up with a system that can do that well. And then besides Dave giving a talk, one of his colleagues will do a 40-minute session deep dive on what the technology and techniques Elemental Cognition is doing to crack natural language understanding.
Okay.
Josh Tannenbaum of MIT, I've long been fascinated by what they do. So basically, they're trying to develop techniques that help machines learn and think like people. So I think one of the things that deep learning is great at is perception and large scale and pattern recognition. But it still relies on a lot of data. And so Josh and his crew are trying to come up with alternative methods for maybe taking deep learning and infusing it with startup knowledge, making it much more efficient and much more similar to how people think.
Okay.
And then I don't know if you followed recently, but a group at Carnegie Mellon, led by Thomas Sandholm, won. I don't know. I'm not a poker player, but one of these poker tournaments where they beat out a bunch of top human players.
Okay.
So it's similar you can think of it, this achievement as basically almost at the scale of AlphaGo.
Right. Okay.
So, but people aren't as aware of it. So he's giving a keynote about this.
Oh wow!
About how they won the tournament.
It sounds like a great lineup.
And so Yeah, and just like the previous conference, we have sessions on many of the techniques that people are interested in, but much more our focus is, we're also going to try to provide a track for people who are interested in how to bring these ideas and technologies and methods back into their organizations and implement them into their products.
Okay.
But we also try to mix it up. I invited a bunch of my academic friends are going to be speaking at the conference about really cool things that industry people will find interesting and maybe kind of spark a conversation and see how we can, be a true gathering place for industry interested in building AI products.
Awesome. Oh, it sounds like it's going to be a great time, and I'm certainly looking forward to it. And it'll be great to, catch up with you in person once again.
Cool. Yeah. And at the risk of putting another plug in, but we also have an AI conference in San Francisco in September.
Absolutely.
And we're still we're I would say 80% there as far as completing the lineup, but it's already looking great, and I'm sure you'll be there too, right, Sam?
Oh, of course. Yep, looking forward to it. Is there a CFP still open for that, or has that been closed out?
That's been closed out for San Francisco.
Okay. All right, great. Well, Ben, thanks so much for taking the time to be on the podcast. It was wonderful having you on. And again, looking forward to seeing you in a few weeks.
Thank you, Sam.
Thanks. Bye-bye. All right, everyone, that's our show for today. We love hearing from listeners about the show. You can leave your questions and comments over on the show notes page at twimlai.com/talk/26, where you'll find links to Ben and the various resources we mentioned in the show. And as always, our quote contest continues. Just drop us your favorite quote on the show notes page or your social media network of choice, and we'll send you a laptop sticker. Once again, thanks so much for listening, and catch you next time.